Hi, boys and girls. Today we're going to go on a field trip, and I'm going to show you the largest instrument that you can play. Now, you're probably thinking, is it a tuba? Wait a minute. I bet it's a double bass. An alp horn? So, here is where our field trip is to today, to find the largest instrument you can play. This is the organist. This is Mr. Ron Pearson. If the name sounds familiar, that's because he's my husband. And he's the organist, choir director here at First Presbyterian Church. And this organ is the largest instrument that you can play. Bigger than a tuba, bigger than an alp horn. So, you got all these keyboards, Ron. 1, 2, 3, 4 keyboards. Is that what it's called, a keyboard?
Well, they are keyboards, but in the organ world they are called manuals because they are played by the hands. So we have a 4-manual console. By the way, this large object is called the console. It's only a small part of the organ. When we say the organ, we're talking about much larger objects, pipes, all sorts of things that you'll see later, but this is the console. This is not the organ, this is the console for the organ. And there are 4 manuals, there's also a pedal board.
Yeah, sometimes I see you playing with your feet.
Now, organists have to play with both feet. There's a large keyboard here of 2.5 octaves of keys, 32 notes, from bottom C up to G here, 2.5 octaves. And that means that there are 5, not 4, keyboards.
Well, you sure have a lot of buttons there.
These are called draw knobs.
Oh, okay.
They're pulled in an outward position there. It's on, and there it's off. It's a switch, basically an electrical switch. And each one has some words on it and numbers, and the words and the numbers explain to the trained organist what kind of a tone it makes, what the sound is like, whether it's a high note or a low note. So the organist is required to memorize everything on the draw knobs, and they all sound different. So when you want, say, the sound of a flute, you get that. If you want the sound of an approximation of a brass ensemble, you do this.
Okay, so you can pull out these draw knobs and get different sounds, but how in the world does that work? I mean, just pulling out a stop or a draw knob? Tell me how that works.
Well, first of all, the organ is a very complicated instrument. There's a lot of technology involved. The pipes are organized into 4 categories of sound. And I don't want to get too technical, but if you want the sound of a certain family of instruments, for instance, in the orchestra you have strings, woodwinds, brass, and percussion. In the organ, there are different terms, but there are also groups of sound. If you want a certain sound, you pull out the knob, that turns on a device up in the chamber that activates a set of pipes that corresponds to that knob. So if you want a flute sound, you pull the knob that is attached internally to those pipes, and you get a flute sound. If you want an oboe, for example, if you want a flute, you get.
So how is the sound produced by just pushing a key?
Well, that's a good question. First of all, let me define some terms here. The organ is a wind instrument, so something has to produce air or generate a supply of air under light pressure so that it can be delivered into the pipes at the right time. And we'll talk about that later when we go downstairs to see some of the hardware. So each key is connected to a mechanism in the chamber that corresponds to the note that we want to play. So if I want middle C to play, there it is. I'm playing middle C and I hear middle C. The control system is all modern, that is to say it's digital like a computer. The cable that connects the console to the chambers is very small, just like a computer data cable. And it's way beyond my knowledge to explain how computers work, but essentially this is controlled by a computer.
Does each keyboard have a name?
And yes, it does. It also has a number, and Roman numerals are used. So Roman numeral 1 is the bottom keyboard. It's called the choir manual. Roman numeral 2 is called the great manual. Roman numeral 3 manual is called the swell. And Roman numeral 4 manual is called the solo. Now, great and swell are not adjectives in the sense, gee, wasn't that a great movie? Or that sure was a swell hamburger. It's not used like that. It's a musical term. It's a little hard to describe in a short video like this. But the manuals do have names, and those are the English-speaking world names. If you go to Germany or France, they would have their own names using their own language.
Oh, okay. Well, you've got this set of little kind of buttons that you can put up here. It says solo to pedal, or
Those are called couplers.
okay.
They couple or they connect the function of one manual to another, and I'll show you that very quickly. For example, this sound is normally played on manual 3. If I wanted to play on manual 1, I just activate that coupler, and now it's on manual 1.
Oh, so in other words, it goes from the swell
To the choir.
to the choir, and
Or
is that
it could go to the great. Here it goes from here to here, or it could go.
okay? Well, you also have a bunch of buttons down below that have numbers on them. Can you tell us what those numbers mean?
Yes, those are called combination pistons, like the piston in a car engine. Different definition, obviously, but the same word. You see so many knobs here that if you had to stop a piece of music in the middle of it and adjust, because these all sound different, and say to the congregation, excuse me, stop singing while I make a change here from soft to loud, that wouldn't work. So what we have are combination pistons. Now if your viewers will watch the draw knobs here, watch what happens. They move. By pushing a piston which has been preset to a specific combination, you can immediately change, for example, from this to this.
Oh, and just by pushing that
Just
piston.
by pushing the piston.
Okay, but what if your hands are too busy?
You use your foot.
You use your foot.
Yeah.
Well,
These are called toe studs.
and toe studs is like they're like pistons.
Yeah, focus on my right foot.
Pistons,
Toe studs.
toe studs that say tutti on them, tutti 1 and tutti 2. That's kind of a funny term.
The Italian word tutti, we get the word total or totality from that word. It means all or everything. And they're also lettered with red ink, and they're duplicated here with red thumb pistons. And it simply means full organ or just about everything. There's also a red light that goes on over here when you push number 1. Push it again, and it's off.
Oh, okay.
I'm playing the keys, but nothing's happening because none of these knobs are functioning.
Okay. Well, then what is the G, C?
General cancel.
Okay.
So watch, again, your viewers can look at the draw knobs here. Watch what happens when I push a general piston.
Okay.
Lots of knobs move out, and we
it's-
have... Now watch when I push the general cancel, watch the knobs and the couplers. boom, they all go back to off position.
Do you wear different kinds of shoes when you play the organ?
Yes, indeed. Organ shoes are made for playing the organ. They are lightweight, leather bottom, rounded, slightly pointed toe, with a tie over the arch, not loafers like this wouldn't work. These are casual, obviously. So you have a 1-inch heel, and you can slide your foot on the pedal board without, if you wore an athletic shoe with a rubber sole, the shoe would stick to the wood and you wouldn't be able to slide.
Oh.
So I use these shoes only for playing the organ. One pair will last me many years. I keep them by the bench, and every time I practice or play for an event, I put these shoes on.
This is weird. What? This is part of the organ? I don't get it.
Well, I said earlier that the organ is a wind instrument. It's defined as a wind instrument consisting of pipes which are playable from keyboards by the hands and the feet. So wind is defined as air under pressure. Wind goes into the pipes. Without air going into the pipes, they are silent. Nothing would happen. So the air has to be generated somewhere. There's air in the room, but it's not going into the pipes. So this is called a blower. This is a large fan device, very large electric motor, and a spinning blade fan like a hairdryer, except it does not heat the air. It's just room temperature air. It discharges the air through this duct. It then goes on up through the building into the chambers, and it's stored there, and we'll talk about that when we get there. It's captured and stored in reservoirs, which you'll see in a minute. So when this starts up, it sounds like a turbine or a jet engine firing up. So here we go.
I'll scoot back.
The organ is being played, this is running always.
Oh, okay. Okay. Now where are we going?
So we are now in the north chamber, just north of the choir loft, and above it, on either side of the window in the front. So we're going into the area where the pipes are located.
Okay.
So we'll stop right here and we'll see two things of interest. The wind that was generated from the blower downstairs is fed into a device like that you're looking at. That is called a reservoir. It's like a bellows, kind of like a fireplace bellows, not exactly, but similar to that. And that's where the air is captured. And if I can get past you here and come over here, this part of the reservoir is movable. It's full now and the air is keeping it blown up. But if these corners are made of leather, and these springs down here are pushing against this part. This is fixed, this is movable.
Okay.
So one half of the reservoir floats, or it moves forward or back or up or down, depending on the demand made on it. And it keeps the pressure steady so that the pipes will always stay in tune with themselves. Because more air going into a pipe will cause the pitch to go up, less air will cause it to go down, either sharp or flat, and then it will be out of tune with itself.
What are all these wooden things here? What are those?
Well, what you are looking at now are the largest pipes in the organ. These are
pipes?
These are pipes. They're made out of wood. They're very long, very heavy. The bottom low C on the pedal board is played by that one right there, which you'll see from the other side is a little easier to spot from the other side. But each one of these pipes plays one note.
Whoa.
That's the way organs are. Every musical note has to have one pipe.
Wow.
So here we are in the area of the organ that is controlled by manual number 2 from top to bottom. Number 2, Roman numeral 2.
Is that the grate?
This is the grate.
Oh my gosh.
So these pipes are played from manual number 2. You'll see pipes of different shape, different design, different material. Some very, very small on this end, the treble end, obviously very, very high pitch, and then larger ones as you go down the scale. The pipes get longer.
Well, if they all play, one of these plays the note middle C, why do they have to be different shaped?
Because you want different tones from them.
Oh.
So this is a flute, stop flute with a red felt around the cap. This is an open flute, an octave higher. This is another octave higher, which is why it's shorter. These are trumpet pipes, the conical shaped ones that shape like an ice cream cone.
Uh-huh.
These are reed pipes. These are flute pipes.
Okay, what's the difference between a reed pipe and a flue
A
pipe?
reed pipe has a brass tongue at the base of it, which vibrates like a hummingbird wing very fast.
Flue pipe.
A flue pipe, that's F-L-U-E. So I'll show you what a flue pipe looks like. This is the flue here, or the mouth. There's an opening there, which causes the air to go through a little narrow opening and strikes the upper lip of the pipe. I'm not sure you can see that.
Yep, I can.
And air going into it makes a tone. Now watch what happens if I blow too hard. It goes sharp and then it flies off. That's the term. It flies off pitch, goes up to a harmonic, and it's very strident and unpleasant. If I don't blow hard enough, if the pressure is too low, watch what happens.
So that's why you have
That's why
air
you have-
under pressure so that it's
Precisely.
equal.
That is
Oh.
why you have reservoirs to keep the pressure steady, so you get this effect.
Oh.
If it's not steady, it'll either do this or this.
Okay, that's a flue pipe with a cap on it,
Yes, it's got a cap. It's like a little,
like a little hat.
like a hat on top of it. Different kind of quality to the sound. But again, steady pitch, steady pressure.
Now, why would they put a little hat on it?
This is acoustically functions as what is called a stopped pipe, meaning it plays an octave lower than a pipe of the same length that's open.
So is that because, let's see, the air goes into it,
Yeah.
and does it hit the top of the hat
Yeah.
and then come back down,
It's
making
come
it?
back down. Now,
Oh,
these pipes are about the same length,
uh-huh,
but listen to the difference between pitch.
okay,
What note is this? This is middle C.
Perfect.
There you go.
so the one with the hat is going to be lower because the vibration, the air
The
vibrates.
column is twice as long.
Oh, because it hits the top and then goes right back
Yeah.
down.
And
I
the
got
red
it.
felt is to keep the cap from slipping downward. The cap is larger in diameter than the body of the pipe, but if you just set the cap on, it would fall all the way down. It would not be in tune.
Oh.
So the red felt is like a gasket or a seal that keeps the cap from slipping. And to tune it, you simply move it up or down.
Okay. So does handling it make it go out of tune?
Yes, it does, because your body heat, 98.6, is absorbed quickly into the metal. This kind of metal, it's called spotted metal. It's tin and lead, alloy, tin and lead, and it absorbs skin temperature very rapidly, and then it transmits that heat into the air inside the pipe. Vibrating air, air vibrating under warmer conditions goes faster than cool conditions. So by handling the pipe, the air inside the pipe warms up, the pitch goes sharp. So when I put this back in, it will be out of tune for maybe a minute until it cools off, and then it's back in tune.
So that's why organists are always concerned about the temperature in
Exactly.
the sanctuary.
Yeah, it's
Got
crucial.
it.
It's very, very important.
Grief, what are these things?
These are very large reed pipes that play 2 octaves lower than the note that's written, played by the pedals. And the metal work here is called mitering.
Is that, well, it's bent.
It's not bent, it's cut and resoldered, because if it weren't, the pipe would be too long to fit into the space.
So in other words, just making a long pipe, just kind of,
Pipe does not have to be in a straight line.
oh.
It can be mitered. As a matter of fact, think of a French horn. It's wound in a circle. Think of a trombone. It's
Yes.
in a loop. If a trombone were unlooped and made in one solid straight piece, you couldn't play it. It'd be way too long. You couldn't handle it.
Oh, well, now wait a minute. What are these little wires that are sticking
They're
out of
called
it?
tuning wires.
Ooh.
Those adjust the vibrating length of the brass tongue, which you cannot see here. I can't lift that up, it's way too heavy. So you tune the pipe either by adjusting the length of the tongue or by the scroll at the top. If you look up there, it looks like a
Oh,
tube
okay.
with toothpaste rolled up.
Oh, okay.
That's a tuning scroll.
So these wooden pipes, this is the front side. They've got a hole cut in them.
Now that's called a mouth. It's
A
not
mouth.
It's not a hole. It's an opening. The air comes out. Let's see if I can get over here and I'll show you. The flue, F-L-U-E, is this little slot right here. That's a narrow slot of air that comes up from the bottom. The air strikes the upper lip in a flat sheet of air, and it causes the pipe, the air inside the pipe to vibrate.
Oh.
And that's what causes the pitch.
Wow, look at these pipes. Now, why are they sitting on the side like that?
Well, these are trumpet pipes that are mounted horizontally. They're not quite horizontal, they're angled up a little bit, but the idea is for visual effect. They look very, very impressive, but also to throw the sound out over the heads of the listeners rather than directly at them. So they project a little bit better when they're mounted in that position.
Do they have a special name?
Yes, they're usually by the French term trumpet en chamade, which I think means trumpet on its side, literally.
Oh.
I'm not.
So
an
underneath
authority on-
that, is that a
That's a wind chest.
wind chest?
Yeah.
Okay.
Yeah, all pipes sit or are mounted on or next to a wind chest. The wind chest includes the mechanism which opens and closes a valve for each pipe, which is then controlled by the keys at the console. Otherwise, they'd all play at the same time and you'd have an awful noise.
Wow. Now this is the side I bet a lot of people don't get to see. Look at that. What's that big white tube?
Which, this one?
Well, both of them.
Those are air ducts. Those are delivering the air from the blower into the reservoir.
So the blower that we saw
Not
delivers
that-
air?
The blower you saw delivers air to the front organ. This, the antiphonal section where we are standing now, has its own blower directly below the floor here.
Oh, okay. What is that?
Well, this is a computer that receives the signals, the digital signals from the console, and it's called a green box for obvious reasons. It processes the keystrokes from the console and little digital signals, and then it translates those digital signals into electrical signals that go out to the wind chest. And it does that through this network of junctions here,
Oh my gosh.
which the gray cables are the new digital signals and the black cables are the old wiring from 1967 when the organ was installed. And those are still wired on to the pneumatic chest actions. So you might wonder what this is. It looks like an electric mousetrap. It's not. This is a pneumatic action. There's one of these for every pipe,
Oh.
and it controls the flow of air. So you see a magnet there. This is wired to the other end of this, and it takes 12-volt signal, and it activates a little pneumatic, and then it causes this to go boop, boop, on, off, on, off, on, off. And there's a felt disc attached here which seals the hole below the pipe so that air cannot get into it. So this is called a pneumatic action. There are maybe 2,000 of these in the entire organ.
How many pipes?
6,520.
So every pipe doesn't have one of those?
Some pipes are served by a common action.
Oh, okay.
So there are not as many actions as there are pipes.
Okay, so again, how many pipes? 6,000?
6,520, and in that total, 1,100 are in the back, and the remainder are in the front.
Okay.
Yes, the organ is the ultimate multitasking instrument, to use that word. We hear that word a lot, but you have 2 hands, 2 feet, or 10 fingers, 2 feet, and you actually have right toe, right heel, left toe, left heel. So there are
Wow.
4 possibilities with your feet, 10 possibilities with your hands, 4 keyboards, 125 knobs, 36 couplers,
And a partridge in a pear tree.
pistons everywhere, turn your pages.
Oh my gosh.
There's a lot to keep track of.
That's for
it's
sure.
very, very challenging to play an organ of this size, or any size for that matter.
Yeah. Okay, so
So we'll end with a piece that you probably have heard before. It used to be played on the TV series called Masterpiece Theater, but it was written 200 or 300 years ago by a French composer named Jean-Joseph Mouret, M-O-U-R-E-T, called Rondeau.